Hello and welcome to the Stardog Academy training on Java. I'm Rafael Campo, one of the software engineers at Stardog. To let you know a bit more about me, I have worked on several customer projects that unify many unconnected data sources using the Stardog platform. I have also developed end-user applications that allow individuals to interact with Stardog by being able to view and manage data across different sources. Today, I'm going to walk you through Java. In this training session, you will learn how to manage and query Stardog using its native Java APIs, manage and query Stardog using its Spring framework support, set up an application to connect to Stardog via a RDF4J or Jena bridge, and finally, understand Stardog's extension points that allow a Java developer to modify certain behaviors to the platform at runtime. Let's get started. This section is about the API overview. In this section, we will get you familiar with the API by demonstrating a few use cases and examples so that by the end of the section, you can feel comfortable to begin querying and manage Stardog programmatically from Java. There are two main parts of the Java API. The first one is called Snarl, and Snarl is an acronym that stands for Stardog Native API for the RDF Language. It gives us the Stardog connections, the ability to send queries to Stardog, do administrative tasks, and basically, everything that you can do from Stardog Studio or from the CLI is backed by a web service and an equivalent Java API. And in fact, it's this Java API that the command line uses, and so it's part of the product and it's robust. The other main API is called Stark and deals specifically with RDF types. So we'll cover how to deal with RDF types and converting those into, for example, POJOs, plain old Java objects that you might have within your Java domain model. So we've got the Stardog API, which you could use to build a client application. This could be an enterprise environment, a web container, or a piece of middleware. From the Stardog perspective, it doesn't really matter. But as most Java software does, it's going to pull in some third-party dependencies, which generally speaking will be up to date. The Stardog API is essentially interacting with the Stardog Server over HTTP. So in one sense, you can think of it as a wrapper on an HTTP client that abstracts away specifics of the HTTP protocol. So you can deal with POJOs and not have to deal with any parsing yourself. The client libraries are shipped with the server and are located in the lib folder. Though most people are going to be pulling these through a Maven compatible repository like Maven or Gradle, and we do publish this on our own Artifactory instance. Some customers will make copies of those dependencies and put them in their own internal Maven repository. We also have top-level artifacts used for dependency management, so there won't be that many options there in terms of dependency management. You just basically add the dependencies to the Stardog API, and you should have everything you need. So we have a couple quick examples. The first one is a Maven pom.xml. It starts with the repository, maven.stardog.com, followed by the two dependencies, the Stardog core, and finally the client HTTP. Note that it is a type POM dependency, meaning that it refers to other dependencies and does pull in the dependency tree. You can use the Maven CLI or the Gradle CLI if you want to print that out, if you have any concerns about third-party libraries that Stardog pulls in. This is an equivalent example in a Gradle build file. If you're not familiar with either Maven or Gradle, both are declarative build tools. Stardog internally uses Gradle for most of its builds, and in some of the open source projects referenced in this training, you'll also see Gradle used. You're not constrained to this type of tooling. However, we do recommend Maven or Gradle for simplified dependency management. So with the build environment set up, we then want to think about the two halves of the API. We've got things that are an admin connection and things that are a user connection. These are essentially the difference between building an application that will perform administrative, operational, or automation tasks for the server versus building an application where you might add data, run queries, and or process results. The admin connection is used less frequently, unless you have a Java-based automation system where you want to create a server, list the databases, automatically add or drop databases, or even add virtual graphs programmatically. Most of the time, you're going to be dealing with the connection object and all of its derivatives. This concludes the section on the API overview. In this section, we will take a look at a few implementations for the admin connections and the user connections. So the Stardog Snarl API provides the connection object. It's very similar to Java's JDBC API, meaning we're going to open up a connection, run a query, get a result set back, and then we're going to have to close the result set and connection. And just like the JDBC, Stardog supports a connection pool using Apache Commons DBCP. Stardog follows a builder pattern for much of the API to be as fluent and to support method chaining as much as possible. We can see that in the first two blocks for connection configuration and connection pool configuration that we're using method chaining to build out the configuration. So we can kind of read it as the connection configuration is going to target a database name, add a server URL with some credentials. That configuration we pass to our connection pool configuration where we add in the min and max pool size as well as expiration blocking specifications. Finally, in the last line, we can use that configuration to create a pool. So essentially, the connection pool configuration is the factory that once fully configured, you have your pool. Then from the connection pool, we can obtain a connection and then later release it. When the application shuts down, we should also shut down our pool. All this is equivalent to JDBC boilerplate, and just like it, it's relatively uncommon these days to fire up the JDBC API and open connections yourself. You can follow a similar design pattern around Stardog. And unlike JDBC API, the Stardog API doesn't implement the Java X SQL interface, so you cannot use JDBC level plug and play libraries with it. However, in the same manner, you might create connection pools where you might tear them down in pre and post processing steps or server startup and teardown steps. You can do something similar here. A good example of this is when we get to the Stardog Spring implementation, we have this boilerplate standardized in a template design pattern. So basically, whenever you want to handle the kind of pre and post processing stanzas, whether it's closer to the application server or closer to the application code, all that is up to you and how you want to design your client application. So moving on to admin connections, we're going to follow the same pattern here. We're going to open a connection, look at some databases, see if one exists, change some parameters, and eventually close that connection. The admin connection follows that similar pattern of opening and closing the connections, and there's not really any specific shortcuts. So looking at this example, we have our own admin connection configuration builder, which builds out the admin connection. In this example, we're not using a pool, we're just connecting using the provided connection configuration, which is also an option under connections as well. Using that technique, you can create single regular connections or create single admin connections. Once we have the connection object, we can start to use some of those methods. And again, we have some examples of fluid method chaining here. But you can start to see things like a list returning a collection and then running a for each over that. We can use a standard Java collections API usage with this. So looking for things like contains database. There's also the ability to create new databases and set options. So in the second to last line, you can see more fluent API in action and then eventually close that connection. Again, this would be something that you would do during the creation of an automated test harness, or if you want to orchestrate any automation around the server like DevOps that just happens to be in Java. The Stardog Java API does use a casting concept to move to other areas of the API. This is present in both the admin side and the application side. And this is done using the as method, which then references the class that you want to cast to. So in this example, we're going to downcast into the VirtualGraphAdmin Connection, which gives us access to a few additional methods that are specific to it, such as adding a virtual graph, where you would pass in a virtual graph name, properties, and the virtual graph mapping. This next one is BITES, which stands for Blob Indexing and Text Enrichment with Semantics, and it's part of our full text pipeline. It allows us to have full control over being able to manage the document store such that we can add documents, retrieve them, reindex, delete, and know how many are stored. In this example, once again, we're going to grab an admin connection and then cast it to the BITES connection using the as operator. And then we can start to manage some documents. In this case, we're going to be adding the document to the store using the put document method. So that covers some examples of administrative level application development, which is again relatively uncommon. In the following slides, we're going to look at your more typical application development. And this is something where over the years, our team has done everything from deploying standard servlets in, for example, Apache Tomcat or Spring Boot. Others have used JBoss or just a standard Java application that might run from the command line. All those are certainly possible, and it's just a matter of hooking in whatever specific frameworks or interface we want where a connection management can happen. Again, most of the time use cases are going to be adding data to the database, running a query, or mapping parameters into that query, marshalling your job objects to RDF types, and outputting the result. We're also going to look at some of those downcasts to some of the feature areas as well. Using the connection configuration from the prior slide, we can use it here to add some data from a file. Similar to the commit and rollback methods of JDBC, we first start a transaction with the begin method. We then have another Fluent API for the adder. So calling the add method on connection gives us the adder object, where we can then process the input and output at a variety of formats and streams. Here we're going to ask the adder to load a turtle file, streaming from a standard Java file input stream, and from some relative location that this program can access. Finally, the last line will commit the transaction to the server. So that's loading RDF data that you might already have. There might be many cases where you have data coming in your application that is already parsed, or maybe it's represented as POJOs in your Java domain model. Or maybe it have come from another system where you just did a web service call and we need to turn that into RDF triples. So in this case, we're going to use Stark and the Values API to create a statement, and here's where the creation of an IRI is possible. Again, you can see that we're using the adder function, which can take one or more statements, and this can be done within the context of a transaction. This could be one way you could serialize data in. Other ways of doing it could be by running a Sparkle update query and binding your input parameters as parameter values to that query. Not just triples, we can also represent quads. The Values API has varg args to it. So here we can say that Miami Dolphins are a great team, and we can also specify the context within the Miami Dolphins fan base. So the inclusion of the graph IRI is also possible here. Once you have the data in Stardog, you're going to want to run some queries. The connection object is going to have different methods that align to the different query forms in Sparkle. Here we're going to take a look at select, which you can see in the first line. We can do a couple things to it, such as set limits or offsets. Then we're going to take that query, execute it, then get the results. Note that the result type will be specific to the type of query that we run. In this example, we have a query result writer API that takes the results, an output stream, and has some formats to it, which in this case is a text table query result writer. That's going to produce a text table very similar to the text table you are presented when you run a Sparkle query from the command line. This also uses the try with resources that will automatically close out the connection when the transaction finishes. Now, one thing we don't want to do when running our query, if we're going to bind a variable, we don't want to start manipulating the query string with string concatenation, as the things that you might have experienced in your career with respect to SQL injection, doing string concatenation to query strings also exist in Sparkle. Obviously, less common as an attack vector, but still an attack vector. So the parameterized query forms align the defense against Sparkle injection attacks. It essentially takes the parameters of the query and sends them along with the server so that it may verify them as well. Obviously, this should not be the sole source of parameter validation. Any application you develop that is taking user input should obviously do validation on acceptable types, limits for that user input. Though we want to support parameterized queries and encourage you to use them for all incoming parameters and not use string concatenation. In this example, instead of taking this query and adding a limit, we're going to add a parameter. We're going to bind a specific article instance to the variable s in our query so that only the properties and the values of those properties specific to that article are returned. The query is executed exactly as before. However, here we decide that we're going to process the results by looping through them in a while loop with hasNext. For every result, we're going to have a binding set. For example, the variable p or the variable o in this query would be a binding on the result set. Then in the code, we can use a binding set to get that result set. If that particular object is not going to be a literal, in this case, it could be an IRI. We can call additional methods on that, like toString. So if we want just the string representation of this, we can again use that Fluent design pattern, a binding set .value.toString. This is also the case where we want to consider how we map our result set objects to POJOs, and most likely convert them from an RDF type to a POJO type. So things like RDF literals, we most likely want them in the format of a string, datetime, double, or Boolean. We don't want to be polluting our Java application with RDF literal objects. We want to maintain a level of abstraction so that our RDF is limited to the input and output against Stardog itself. And that's good Java design practice. It's the exact same way with JDBC, as in you don't want to pollute your JDBC objects into the front end layer. Just as Admin Connection had VirtualGraphAdmin Connection and BitesConnection, user connections can be casted to different parts of the API as well. First, we'll look at Reasoning Connection. This will take advantage of Stardog's reasoning capabilities. Next, ICV, which stands for Integrity Constraint Validation, and it allows us to enforce and validate the shape of the graph. Finally, Search Connection, which provides access to Stardog's full text search feature. Integrity constraints are something that you'll develop as RDF, meaning that you're defining the shape of the graph that should exist. You can then load that into Stardog from either command line or web service and get a report out on the state of the data quality in your graph. So it is possible to orchestrate or automate ICV just as with the rest of the API without resorting to a programmatic interface. However, if you're going to develop a data quality type application and you want to process the data quality results, then our Constraints API is a great way to do that. In this example, you can see the constraint factory has a Fluent constructor for making a constraint. You can also use different parts of the constraint language, like subclass of products, to create a constraint. From there, we can add the constraints to the validator, which was pulled from our connection object, and down at the last line, we can check if the data is valid or not, and print the results. A more practical use case for this API could be to automate the repair of certain data where you have no control of the application or web service that first gets it. So for example, if you knew that the users often entered their dates in an improper format, you could create an algorithm alongside this API that checks for the error, flags it, and fixes it. The reasoning connection takes advantage of Stardog's reasoning capability. Now, the SPARQL syntax of a reasoning query and a regular query will look exactly the same. You're only just taking a different part of that query, like a class definition in the object position, and typically referring to an inferred type. So having a class hierarchy that you can query at a higher level abstract class will tell Stardog to do the join on the fly, leveraging the inference engine. In the example, we take our regular connection object and do the as cast to the reasoning connection class. Therefore, it sets the reasoning parameter to true on the HTTP connection. From here, we can do our select and do a bind on the type variable in our query string to person. In this case, person is the parent class within the context of our learning dataset to things like artist. So by querying a higher level class where artist is the subclass of the person class, we will get all people, including all artists, as the answer to this query. So simply by taking advantage of the declared ontology that got added to Stardog, we have leveraged inferencing. Though there might be cases where you may not want to run queries with reasoning, and others where you might, turning reasoning on or off, or having a reasoning connection versus a regular connection can be a division that you might want to design into your application. On some applications, we could use reasoning for everything, and it may just be a parameter that we set on our connection pool and take advantage of it fully. Other times, we might have regular connections and cast them to a reasoning connection as needed. It all depends on the setup of your graph, how much ontology usage you have in your graph, and what type of queries you want to run. Finally, we will look at the search connection class, which gives us the additional capability to add in search parameters without having to resort to SPARQL. Note that since the RDF index is no different than the full text search index, you can search via SPARQL, or in this case, directly from Java. Looking at the example in the first two lines, we first downcast the connection to our search connection class, and this creates the search connection object, which is used to conduct the search. The next line sets the search parameters, first by creating the searcher object with the search method. The limit method will restrict the result set to 50. The query method will set the query string to max, and finally, the threshold method will retrieve results with an overall score of 0.5. Finally, in the last two lines, we execute the search and use the iterator to go through the results. We've also demonstrated here an additional set of methods in terms of getting a result hit and its score. This concludes the section on working with the API. This section is about the Stardog Spring Framework bindings. In this section, we will take a look at Stardog Spring Framework integration as an option to bootstrap application development. Like with any Spring project, there are some Spring-aware beans that we provide that will participate in the dependency injection capability. Essentially, Stardog Spring is looking at the baseline Stardog API and mimics things like Spring's JDK template. This works by implementing a template design pattern that abstracts the boilerplating for transactions and connection pools. For example, a data source factory bean will manage your connections and connection pools for you. There's also a few utilities for doing things like imports, and Stardog Spring Batch, an additional library that implements the item reader and item writer interfaces from Stardog Spring so you can build ETL pipelines. So we're looking at a Spring application context in the traditional XML format. We have a data source factory bean that takes in things like the database name, credentials, whether visiting should be on or off, the server URL, all as properties. The data source factory bean then gets injected into our Snarl template, which will end up as the bean that you'd want to inject into your business objects. We also have the data importer that can be used to load fixed data and can be useful when setting up a test harness. It takes the Snarl template, the format that's going to be loaded, and then one or more files using a standard list. The data importer uses Spring's resource loader, so it understands the class path prefix that you see here. Now typically, you'd have your main pull in your Spring application context. Here's a straightforward example of just making an application context directly by getting the bean template into our program and getting a fully configured Snarl template. This would take care of all the init methods in terms of creating a connection pool and managing transactions for us. Now a Snarl template, if injected in typical Spring application, would not be null, as that's guaranteed by the dependency injection. Here we can take our Sparkle query, pass that to the template, which then wants a query, and in this case, the simple RowMapper automatically maps things to a list of maps of string. This is a nice utility to quickly just run a query, get the results, and then print them out. To enable reasoning, remember that there's an additional property to turning reasoning to true in our application context within our data source factory bean. We can also do this in a couple of places in the application code, just as we discussed earlier. This slide presents the RowMapper, which essentially maps our binding set into the resulting type of our choice. Again, we don't want to pollute other areas of our application or even other processes downstream with binding set objects. In other words, we don't want to take the binding sets of RDF literals and pass that into our UI layer or other business logic. So the RowMapper concept is a type of class where we can convert the binding sets of a query result to a type that we need it in. All we need to do to make it work is to implement the mapRow method, which just takes in the binding set and the type that you want the results in. Then the Snarl template will take that type and put it into a collection, in this case, a list of maps. You will also notice here that the query method is overloaded with an extra parameter called params. While the earlier example we saw just took in a query and a RowMapper, this one takes a query, a parameter map, which binds the DC title IRI to the C variable in our query, and then finally the RowMapper. This block here is probably the most typical we want to have in terms of using a Snarl template and building a Spring-based application. This concludes the section on the Stardog Spring Framework bindings. This section is about testing. In this section, we will discuss how the embedded server that ships with the API can be used to build out your tests. The embedded server solves the problem of having to start and manage a server outside of a Java program and allows tests to run in isolation as they should. Now it is a full Stardog server and requires all the normal configurations, such as a license key and a Stardog home environment variable to be set. In the example, you can see the Stardog object, which builds out the server, and then the additional method on the admin configuration to embedded server is used to connect to it. The embedded server is also accessible from Stardog Spring. By adding the embedded provider bean shown at the very top of this example to a property of the data source factory bean, we can have this added to our application context. This example actually comes from the Stardog Spring test suite and demonstrates setting up the data source with an embedded server that was injected into the application context that we saw on the previous slide. So for every test run, this before method will set up our simulated server environment, making sure that the data source is not null and creates the Snarl template. It also adds in some data, so that prior to each test, we will begin with a clean data set. This concludes the section on testing. This section is about third-party interoperability. In this section, we will move on to the third-party Java libraries that are also supported by the Stardog API. One of the popular libraries that provides interfaces for running queries and marshalling in RDF is RDF4J. The only Stardog addition you'll need in your code is that instead of a typical repository connection, you'll use a Stardog repository with the connection configuration API to create a RDF4J repository. So with the repository created, all subsequent RDF4J API calls will all be backed by Stardog. And you'll still be able to do things like get a normal repository connection as shown in the example. And the idea is to be as interoperable as possible with the third-party API so that integration with Stardog is as easy as possible, and that's all that's required is a 1 or 2 line change. The same thing is true for Apache Jena. This has the Stardog Jena factory that we can back with the connection object and create a Jena model off of. Now Jena's model API is slightly different than a connection, and so if you're going to use the model API to do things like compare models, that's the equivalent of comparing graphs. Therefore, the granularity of the Jena API is a little different with respect to what we have talked about so far in this training, and could be doing more work than you might be expecting. This concludes the section on third-party interoperability. This section is about extension points. So that concludes all the typical ways of building client applications with Stardog, meaning that we take that Stardog library, bundle that into our own Java program, whatever that may be, and we're in the client-server architecture. In this section, I'll be going over the Stardog extension points, which live on the other side of that interface, as in on the server. These extension points are things that you'd have to build a jar file for, and that'll get loaded into the Stardog Server using the JDK ServiceLoader, which will make your code part of the Stardog Server's runtime. The biggest caveat on these sets of features is that they're typically for advanced use cases, and you'd want your extensions to be rock solid, because if your extension has a bug in it and it crashes the JVM, well, you've just crashed your server. So there's a few that we have available here. We have HTTP handlers that let you create custom web services on top of Stardog. We have a transaction listener for doing things that would monitor transactions going in. We have ways of customizing the search analyzer in Lucene, so if you wanted to run a different search algorithm or provide additional language support, you can do so. If you wanted to implement your own Sparkle functions, you'll be able to do so with a query extension. Finally, there's a describe extension, which will allow you to change the output behavior of the describe query. Stardog already has a few implementations that can pick up in terms of describing a URI and getting the data out of the graph that supports that URI, but you can change that however you wish. This concludes the section on extension points. That concludes the Stardog Academy training on Java, where we reviewed how to manage and query Stardog using its native Java APIs, manage and query Stardog using its Spring Framework support, set up an application to connect to Stardog via RDF4J or Jena Bridge, and finally, understand Stardog's extension points that allow a Java developer to modify certain behaviors to the platform at runtime. Thanks for following along. Please note that there are additional reference links located within the slide deck in the resources section of the training website. If you have any questions, please review our frequently asked questions page or head to docs.stardog.com for additional information.